we first started this unit, we talked about 3 ways to solve systems. The first way we did was graphing, where we graph each line and find the intersection. Good. And the intersection point is our answer. We want to find out where the equations are equal. Then last class, we talked about the substitution method. And the substitution method is helpful because we can't do everything on the graph because, say, it intersects in between a box, and we don't know if that's what kind of fraction. We don't know if it's 1/2, we don't know if it's 3/4. So we did substitution. And substitution we did with problems such as number 3. We had problems kind of like number 3, where one of our variables did not have a coefficient. But what if we encounter problems such as number 1, in which none of our variables have a coefficient of 1? So our new method today is called the elimination method, or linear combinations, in which it allows us to more easily get rid of one of our variables instead of having to do substitution. Because if I tried substitution here, let's say I tried substitution with number 1. Let's say I was trying to get x by itself. So I would add 3y. And don't write this down, I'm just showing you why we have our other method here. 2x equals 3y plus 8. Divide by 2. X equals 3/2 y plus 4. Then you'd have had to take this entire thing and put it into my equation up here. And you would have had to do a fractions. And that's not as nice as our new way today. So our new method today allows us to simplify our equations when we have coefficients for all of them. Okay? So at the top there, today we will learn a 3rd way to solve systems, and it's called... Can you see where that other marker went? Do I really? Thank you, Abby. Okay, so today we will learn a 3rd way, and it is called linear combination. And you might hear it referred to as elimination. I think that one's more commonly known as. I call it elimination. And what we're doing is eliminating one of our variables. Okay, so what we want to do is we need to make sure that our like terms are in columns. So we rewrite equations with like terms in columns. You'll notice number 1 already has the x's in one column, the y's are in the next column, and my constants are in the last column. If it's not already that way, such as number 7 on the back, then you need to make sure that you get them in the same column. So my x is already in the same column, but you need to subtract your y over so that your y's would be in the same column. Okay? So you need to make sure they're lined up nicely, such as we see here for 5, a, b, constant. And then a problem like number 8, you need to rewrite it so that you have your first variable, your second variable equals, and then the constant. Right? So make sure like terms are in columns. And then our next step after we've done that is multiply each equation by a number to obtain opposite coefficients. For one of our variables. What is a coefficient again?
The number in front.
Go ahead, Abby. Okay, Jenny?
The number in front of the
Very good. The number in front of the variable. So for number 2 here, 6 is a coefficient, -2 is a coefficient, 3 is a coefficient, and positive 2 is a coefficient. What does it mean if they're opposite coefficients? That's good. They're on either ends of the number line, which means one is negative, one's positive. Very good. So opposite coefficients means we want one of our coefficients to be positive and the other one to be negative. And you can see that here, number 1, they've already done that for us, where y has a positive 3 and my other y has a negative 3. That's what we're trying to get. Because after we've accomplished that, then we add the 2 new equations. Because watch what happens when we add these together. Since we have opposite coefficients, what's positive 3y minus 3y? 0. These cancel out, so that I end up having just 6x equals 24. So notice I now have only one variable to solve for. So we want opposite coefficients so that when we add them together, one of our terms cancels out. Alright, so step 4. After we have added our equations together, anybody know what that blank is? Solve. Good, we solve for the second variable. So I would solve for x here. And then after I solve and get my answer, I substitute that value into one of my original equations. So substitute. So here, after I solve for x, I get x equals 8. And then now that I know that x is 8, I put that back into one of my equations up here. Just like before, substitution, we got one of our variables alone, solved for that, and then we got it back and put it back into our equations. Okay, and remember you write your solution as an ordered pair, which looks like this, x comma y.
Isn't 24 divided by 6 4?
You are correct, Evan. 24 divided by 6 is 4, not 8. Thank you.
Ooh.
That is most certainly correct. That would have been a bad move later. Alright, so we write our solution as an ordered pair. And we should check our solution of both equations. We haven't been doing that as much as we should be. You can use your calculator to check it to make it go. So let's take a look at what this actually looks like. No. Let me walk through this first. Alright, so I'm going to go ahead and walk through number 1 step by step for you. We're going to go slowly and explain every single step. So pay attention, let me know if you have questions. And then I'll give you a chance to do number 2 in a little bit. Alright, so again, we need to have our coefficients for one of my variables be opposite. The same number but opposite. I see that my y's already have that, a positive 3 and a negative 3. So since they already have that, I can continue and add my equations together. So we should all be writing this down. Opposite coefficients. One positive 3, one negative. Alright, so we're going to add these together. What is 4x plus 2x? 6x. Positive 3 plus negative 0. 0. There's our equal sign. 16 plus 8. 24. Okay. Now I need to solve for x. Divide by 6. 6 divided by 6 is?
0.
1x. But we can just write it as x. If it was 0, it'd go away. We'd have that. 1. And 24 divided by 6 is 7. 4. Very good. So now we have our x. So are we writing all this down, Louise?
Mm-hmm.
You didn't write anything. Then you have to multiply by a number to get opposite coefficients. So we'll do that one on the next one. Okay, so now that we have our value for x, we take that. Krista, what do we do with that? You take this and put it back into one of your equations. It does not matter which equation you use, just one of your originals. I'm just going to use the first one. So 4x, but I know x is 4, so 4 times 4 plus 3y equals 16. So again, I took my 4 here and put it in for x. Right, now I solve. 4 times 4 is 16.
These are long.
These are long problems. And then I need to get y by itself. Remember, we add or subtract first. I need to get rid of my 16. It's a positive 16, so I subtract it from both sides, which is 0 there, And 16 minus 16, 0.
Aren't we supposed to get y by himself?
Yep, when you get y by itself. So what's one more thing I need to do here? Divide by 3. And 0 divided by 3? 0. So I have my x value, I have my y value, put it together in your ordered pair. And we always go alphabetical. X becomes before y in the alphabet. So that's the one. So this is my final answer. So it's similar to substitution in that we're trying to get rid of one of our variables, but it's a different way of getting rid of that variable. This is actually my favorite one. For substitution, sometimes you have to distribute. There's a lot of work. Alright, so let's take a look at number 3. Right now, do I have opposite coefficients? No. And if I look, I have 4 and negative 2, 3 and positive 1. So I need to make it so that I do have opposite coefficients. Let me say this in some things. Okay, so I look to see what's the easiest thing I can multiply by. So I could either multiply negative 2 times 2, so it's negative 4, that would make it opposite. Or I can multiply 1 times negative 3 to make that opposite. Either way, you can do either one, it does not matter. But when we multiply, we have to multiply the entire equation by this. So I'm going to go ahead and choose to get rid of x here. So I need x to be negative 4 instead of positive 4, so that way it'll cancel out. So I'm going to multiply the entire equation by 2. Entire equation by 2. When I do this, I have to distribute. 2 times negative 2x is negative 4x. Distribute again. 2 times positive y is positive 2y. And I must distribute it to my last piece. Equals 2 times negative 2 is negative 4. So I was asked, where do I get 2 from? What I'm doing is I look at this number here. I say, what can I multiply by to make it so that it is negative 4? Well, negative 2 times 2 is negative 4. Because I'm trying to get one of these to be the same, the opposite coefficient. So if I multiply this by, let's say, 5, that would give me negative 10. That's not going to cancel out. If I multiplied it by negative 1, that gives me 2. That's not going to cancel out. I'm trying to get it to be negative 4, so it cancels out with my 4x here. I could have done this instead with my y's. What would I need, if I wanted to get rid of my y's, what would I need to multiply by here?
1.
If I multiply by 1, then I'd have 1y. 3y plus 1y is 4y. Negative 3, right. I need my coefficient here to be negative 3. Well, 1 times negative 3 is negative 3, and that would cancel out. So I need to multiply by whatever it takes to get rid of that other number.
What if it's a fraction?
We won't give you a fraction with it.
Are you sure?
Here.
What should we doing?
What'd you say? What'd you say?
Well, the decimal.
That's all. Even in algebra, you won't have fractions. But what you could do if you had a fraction, say you're going to the grocery store and someone jumps out of the cereal line and gives you a problem like this with a fraction in it, it might be.
There are people out there smarter than I do.
Watch out. But if there was a fraction, let's say I had 2/3 x plus 5y equals 10. How do I get rid of fractions in problems? Multiply, yeah. I'd multiply everything by 3, because that would cancel out my fraction here.
Okay.
But you don't have to worry about that. We won't be.
We still haven't covered the last. We haven't covered number 6 in the solving systems part.
The right as an ordered pair, and check your solution. All right,
Sorry.
that's okay. Okay, so my new equation here is negative 4x plus 2y equals negative 4. Alright, so I'm going to add that to my equation on top. I'm going to go and rewrite that equation just so I don't have to deal with all of this in here. So I'm going to rewrite that fraction. So 4x plus 3y equals 24. Okay. Now that I have opposite coefficients, I'm going to add these together. They must be opposite coefficients. All right, negative 4x plus 4x is 0. 2y plus 3y, 5y. Negative 4 plus 24. So again, I changed my equation here to have the same coefficient. The only way I can do that is by multiplying by the same thing on both sides. So the entire equation here. That allowed me to have opposite coefficients, so when I add them together, they cancel out. If I would have added it together in the beginning, I wouldn't have canceled out one of my variables. I need to eliminate one of my variables. Great, so now we solve for y. Let's divide by 5 on both sides. 5 divided by 5 is 1y, which is 4. And 20 divided by 5? So I have my y variable. Alright, which one do you want to put it back into? The top equation or the bottom equation? Bottom? Okay.
Does it really matter though?
Doesn't matter. You can use either one.
You'll get the same answer.
You'll get the same answer. Because the definition of the solution to a system of equations is the x and y value that work for both of them. So it should give you the same thing. Alright, so I'm going to take my y here and put it in for y in my equation. So negative 2x plus y, and y is 4. Equals negative 2. So again, instead of writing y, I'm putting what y is, it's actually 4. So now I need to get x by itself. So I subtract 4 from both sides. So I have negative 2x. Positive 4 and negative 4 cancel out. Negative 2 minus 4 is negative 6.
No, I mean,
That's 1. Alright. Then we solve for x. Divide by negative 2. Divide by negative 2.
yours, not mine.
Negative 6 divided by negative 2. Positive 3. Good. Again, we write our answer as an ordered pair. So my final answer, 3, 4. X comes first, then Y.
Where did you put the 4? This 4.
This one. So we picked our bottom equation. I took this 4 and I put it in for Y. So negative 2x, plus Y, plus Y, which is 4.
If you would have done it with the top one, how
You get the same answer. If you would have put 4 in my top equation for Y, you would have got the exact same answer. Because a solution to a system is the same x and y value for both equations. You look like you don't believe me.
I do.
Alright, other questions on number 3? Alright, so I've shown you one that's really simple in that they already gave you opposite coefficients. I've shown you one where we had to multiply one of my equations to get opposite coefficients. So now I'm going to show you the hardest kind. Number 5. So flip your paper over to number 5. So when we did this last problem here, I noticed I said, oh, well, I can multiply negative 2 times a number to get negative 4. That's not too bad. Mr. Rapper, you
What?
Rapper. I thought you...
He is.
And I could easily multiply 1 to get to 3. Now, when I take a look at my numbers in number 5, can I multiply, because remember, we want opposite coefficients. Can I multiply 4 times something to get 3? No. You could, it's a fraction though, but we don't want to multiply by a fraction. Can I multiply 3 times something to get 4? A whole number?
No.
Can I multiply 2 times a whole number to get 5? Can I multiply 5 times a whole number to get 2? No. So we're going to multiply both equations. The easiest way to do that is just to use the coefficients they gave you. So what do you want to get rid of, A's or B's?
So confused.
A's?
These.
Oh,
Raise your hand for A. Raise your hand for B.
B.
Okay, we'll go B. We'll go B.
What?
Alright, so I need to get so that my coefficient in front of B is the same number but opposite signs. So the easiest way to do that is just to multiply by the other coefficient. Here I'm going to multiply the whole equation by 2, because that'll give me 10 for B. Then here I'm going to multiply the entire equation by 5, but it needs to be negative.
Oh my god, I'm confused.
So let's take a look at it. Again, step by step. I need my equations to have opposite coefficients. We decided we're going to get rid of B. That's the column we're going to get rid of. I can't multiply 2 times anything to get 5, and I can't multiply 5 times a whole number to get 2. So I needed to multiply both equations. My first equation, I'm just going to multiply by 2. So let's see what that gives us. I'm going to just write it off to the side. Distribute. 2 times 3a. 2 times 5b. 10b. 2 times 6. 12. Alright. Now my second equation, I need to get my coefficient here for b to have the opposite sign, but the same number. 2 times what gives you 10? 2 times what gives you 10? 5. Yeah, so notice I'm just using my coefficient calculator.
It's not
And I need it to be not just positive 10, but negative 10. So, right, because if I had a positive 10 here, what's 10 plus 10? 20. We're trying to get rid of it. We're trying to cancel it out. I don't want more B's. I want 0 B's. So I'm going to multiply this whole thing. Multiply the entire thing by negative 5. Negative 5 times 2 is
We can get negative.
nowhere.
I want these coefficients to be the same, right? Can I multiply 2 by a number to get 5? No, so we've got to do something else. Can I multiply 5 times some number to get 2? No, so we've got to multiply both of these. The easiest thing is to do 5 times 2 and 2 times 5, because that'll give you the same number. Alright, so let's distribute my negative 5. Negative 5 times negative 4a.
Negative 20.
Close. Positive 20. Good.
28.
Negative 5 times positive 2b.
Yeah, 10.
Good. Negative 10.
Oh,
See, now those are going to cancel out, right? That's what we want.
yes, sir.
And negative 5 times 5.
Negative 25.
Negative 25. So again, I just multiplied by whatever the other coefficient was. So that way they're the same thing, but one is negative, one's positive. Okay, so make sure that in the end, this is a negative. If this was still positive, what could I multiply by to make it negative?
25.
Let's say that I just multiplied by 5. That would give me positive 10b. I can multiply the whole thing by just negative 1. Right? If I need to become negative, I can just multiply by negative. Alright, let's add these together now. What is 6a plus 28?
26.
What is 10b plus negative?
It cancels out.
And what is 12 plus negative 22? You're just so quick.
It's in my head. It's in my head.
Lying.
You can't help it.
Nothing with that calculator in front of you. All right, let's divide by 26 on both sides.
We're gonna have a fraction.
Ooh, we get
Yeah.
a fraction. I love fractions.
I hate it.
Negative 13 over 26 reduces down to
one.
negative 1 time.
Listen, I'm gonna calculate.
Any calculator?
3 still 3.
Oh, that's right.
I'm waiting.
I'm sorry. Wow.
Just because it's a science class.
Leave me alone.
So much.
And then you'll be talking to me.
That's what friends do.
You don't want me to call home?
No.
Hola, mi mamá.
I get too many text messages.
Ah. Okay, so we have our A value. Alright, do you want to use the top one? Are you sure? You can use either equation, but let's take a look at this.
See?
This is 1/2, right? Negative 1/2.
You said that.
You said we won't have a fraction.
Yeah.
For an answer, but you won't have a fraction within your problem. Like, I won't start you off with the problem as a fraction.
Oh.
You can get fractions for answers. You can get decimals for
Not
answers.
how we get rid of it.
Well, that's your answer. That's your final answer, so you don't get rid of it.
Oh, that's it.
For A, yeah, but now we need to find B. Alright, so the reason why I'm hesitant to use the first one, because if I put negative 1/2 in for A, what's 3 times negative 1/2?
3. I don't know. Let me use a calculator.
It's 2.5.
Right, it's a fraction, right? So we can do that, but then we have to deal with the fraction. I like to not have to deal with this. If I do negative 1/2 times negative 4, what is that?
Positive.
2. So that's a nice whole number. So let's go with the second one. You can definitely use the first equation. You can use either equation. I'm just going to use the second one so I don't have to deal with those fractions. Okay. So I'm taking A and putting it in for A of my second equation. So negative 4 times negative 1/2 plus 2B equals 5. Again, when you do fractions in your calculator, make sure you put parentheses around it. Okay, so negative 4 times negative 1/2 we said is 2 plus 2B equals 5. Alright, how do I get B by itself? What's my first step? Good, subtract 2. 2 minus 2 is 0. We're trying to get rid of it. 2B equals 5 minus 2?
3.
See?
A little bit of fraction.
And then divide by 2.
3 over 2.
Good. B equals 3/2, which is 1.5. Alright. Are we done though?
No.
What do we have to do? What does our final answer always have to be? What
X and Y.
Ordered pair. Good. X, Y. Here we have A, B, so we go alphabetical. A comes first, then B. So 1/2, 3/2. A, B plus. Okay, this is our answer. You'll notice on your homework you got some fractions as well. Alright, questions on that? Okay. So what we're going to do next is I'm going to have you actually do a couple practice problems. And while you're working on a couple practice ones, I'm going to pass out the makeup work for those of you that need to do makeup. So I want you to start off with an easier one. I want you to go back to number 2 here, where they already have opposite coefficients. And I want you to start off number 2. You may work with the person next to you. So while you're doing that, I'm going to pass out makeup work for you to do. I also have progress reports for you guys, so I'll pass that out as well. And then we'll come back to it. Our answer for number 2 should have been 1, 2. X equals 1, Y equals 2. And then for number 4, so for number 4, you have to multiply by -1 for one of these. So either equation doesn't matter. You multiply by -1, and that gives you -1x plus 3y equals 0. And then now if I rewrite this over here, x plus 10y equals 13. Now when I add these together, they're opposite coefficients. Okay, so for number 4, you should have gotten 3, 1. Anybody get that? 3, 1.
Yeah.
Yeah? Number 2? Alright, so let's take a look at number 2. Alright, so number 2, they already have that our y's have opposite coefficients, so we can go and add this together. So 6x plus 3x is 9x. Negative 2y plus 2y cancels out. 2 plus 7 is 9. So divide by 9. And I get x equals 1. Did you get that part? Awesome. Alright, and then Jenny, which equation did you plug back into? Okay, so we'll put it back into our original equation, the top one. So 6x and x is 1. So 6 times 1 minus 2y equals 2. And 6 times 1 is 6. Minus 2y equals 2. Alright, and then Jenny, what do you think our next step would be? Good, subtract 6. Negative 2y equals negative 4. And divide by negative 2. And our negatives cancel out, so we have 4 divided by 2 is positive 2. Oh, okay. So you probably just lost your sign. Okay, so let's take a look at number 6 together.
Number 4.
Uh-huh.
I get the negative.
Alright, let's take a look at 4. You said you got negative 3 for x? Okay, so let's take a look at what we have here then. Negative 1x plus x, those cancel out. 3y plus 10y is 13y equals 13. Divide by 13. And y equals 1. Did you get that part? Awesome. Okay. So then, Abby, which equation did you use? The top one or the bottom one? The top one? Okay. So let's put this back into my top equation. So x minus 3y. And y is 1. Equals 0. 3 times 1 is 3. So when we add 3 to both sides, that cancels, and we get x equals 3. Alright, questions on 2 or 4? Alright, so let's take a look at 6, the trickier one. Alright, for number 6, what do you want to get rid of, the Q or the R? R? Okay. So getting rid of R, I'm going to multiply my top equation by 3. So that gives me 9Q times, negative 15R equals 24. Okay. And then, Ginny, what do you think I'm going to multiply the bottom equation by? Good, 5. And when I multiply that, it will give me a positive 15. So negative 10Q positive 15R and equals positive 15. So now when I add these together, 9Q plus negative 10Q, that's going to give me a negative 1Q. Negative 15 plus 15, that cancels out. 24 plus 15 gives me 39. Okay, so then we still don't have Q quite by itself. What do I need to do here? Right, divide by negative 1. So Q equals negative 39, pretty big number. Alright, so do you want to put that in your top equation or the bottom one? so let's do my bottom equation. Negative 2 times q, which is negative 39, plus 3r equals 3. So negative 2 times negative 39 gives you 78. Positive 78. Plus 3r equals 3. And I subtract my 78 from both sides. So 3r equals negative 75 divided by 3. And I get r equals negative 20. So you get pretty big numbers. That's not good. I used to do that all the time at my other school. I'd knock out the form. Okay, so we have r is negative 25, q is negative 39. Remember, we go alphabetical. So you see P, Q, R. Q is first, good. So we write my q comes first, negative 39, and r just negative 25. And if it helps you out, just put q, r. That's my answer. Okay, questions on those ones? Okay, so let's take a look at the next one to make sure we line it up nicely. Number 7 and number 8. So again, we need to have our variables in the same columns. So my x's are in the same column, but I need to move my y across this equal sign because my equals aren't lined up. So subtract y, so I get 5x minus y equals 30. Alright, so my top equation, let me rewrite that. X plus 2y equals 5. Alright, so then you can continue from here. Either multiply my top equation by 2, or you can multiply your bottom equation by 2. Now let's take a look at the setup for 8. I want to make sure we get this right.
What do you do the first one?
What did you say?
No, do you want to do the first one?
Yeah, so I went ahead, I wanted to show you how to get this lined up correctly. I need to move my y over, so I subtracted y from both sides. So I have 5x minus y equals 3. And then I just rewrote the top equation. So that now it's lined up x's, y's, constants. So you can either get rid of your y's, you can get rid of your x's. Since my y's have one positive, one negative, I'd probably get rid of that instead. So what would I need to multiply my top equation by so that it's negative 2? Okay, so I'd multiply the top equation by 2. So then I would have, let me just write this down here. 2 times 5x is 10x. 2 times negative y is negative 2y. 2 times 3 is 6. So then I can add my two equations here together.
So then it's 2 times 2y by 1.
Well, since they're already opposite coefficients, you don't have to multiply anything. So it's like that second problem we did, where you only had to change one of your equations. Otherwise, you'd have to change them. Once you got them the same, you don't have to keep changing. Okay, so then let's do number 8 to make sure we get that set up correctly. So I need to move, because I normally have x, y equals some number, right? So I have my g's, I need to move my h over, so add h to both sides. So this becomes 4g plus h. And negative h plus h, those cancels, that's just 0. C. Alright, and then for my bottom one, I have g, I have h, but my 5 should be on the other side of equals, so add 5. So negative 5 and positive 5 cancel out. So this becomes g minus h equals positive y. And then, Jenny, would I need to multiply anything here, or do I already have opposite coefficients?
You don't have to multiply.
Right, because I already have opposite coefficients of a positive h and a negative h, right? So that we can go down together. So if you didn't get 7 and 8 yet, go ahead and do those. And then we're going to come back together and go over homework and take the quiz. Alright, so we set up problems 7 and 8, so let's go ahead and go through and finish number 7 here. So remember what we're trying to accomplish is that we have opposite coefficients. When I looked at my original equations here for number 7, they were actually not even in the same column, so I had to move my y's. I had to move my y to the left so I could have my x's in the same column, my y's in the same column, and my constants in the same column. Now after I got them all in the same column here, I rewrote my top equation so that I could focus on that there. And then now we're trying to accomplish that they have opposite coefficients. So I see that my top, I could actually change either equation. I could multiply my top equation by 2, so I get my y's to be opposite coefficients. Or I can multiply my bottom equation by -5, so that they have opposite coefficients. I went ahead and chose to multiply the top equation. So I multiplied the top equation by +2, so that I could have my coefficients be opposite here. So 2 times 5x gave me 10x, times -y gave me -2y, and times 3 gave me 6. So now I have my 2 new equations here. Alright, so these are what I'm adding together. And when I add these together, I get x plus 10x is 11x. 2y and -2y cancel out. 5 and 6 is 11. So then divide by 11, I get x equals 1. Alright, now that I have my x value, then I can go ahead and put that into solve for y. Again, you can use either equation, it does not matter. Just pick one and put it in. Alright, so I'm just going to use my top equation. So I'm taking 1 and putting that in for x. So where I see x in my equation, that's where I'm going to put 1. So instead of x plus, I have 1 plus 2y equals 5. Then we solve for y. So subtract 1 from both sides. 2y equals 4. Divide by 2. Should be able to, you guys should be solving pros at this time. 4 divided by 2 is 2. So I have x is 1, y is 2. And that's my order of pairs. Again, always write it alphabetically. Okay. Now let's take a look at number 8. So here we had to reorder both equations to get them in the same column. Again, we like to have a variable, then the next variable, then my equal sign, then my constant. So here we have g's first, and I need to move my h over so they'd be in the same column. And I need to move my 5 over so that it would be on the other side of equals. So when we added h, we end up getting 4g plus h equals 0. And when I added my 5 to the other side, I had g minus h equals 5. So now notice they're in the same column. G, h equals constants. Alright, so now let's go ahead and add those together. So when I add these together, I'm able to add them together because I see that my h's have opposite coefficients, positive 1h, negative 1h. So when I add it together, I get 4g plus g is 5g. H minus h is 0, so those cancel out. And 0 plus 5 is 0. So then divide by 5, I get g equals 1. Again, with elimination, you can see that we much more quickly arrive at our first solution. Alright, let's take g and put it back into my original equation. I'm going to go and take my first equation here. And again, I'm taking 1 and putting that in for g in my equation. So instead of 4g, I have 4 times 1 equals negative h. So I have 4 equals negative h, but I need to get h by itself. So same thing as negative 4h. So divide by negative 1 on both sides. I get negative 4 equals h. Alright, again, alphabetically. So A, B, C, D, E, F, G, H. G comes first, so it's 1, negative 4. And this is my final solution. Alright, so again, our steps here. We need to make sure equations are in the same column, or get our variables in the same columns. If not, you need to move things around. Remember, to cross that equal sign, you have to do the opposite operation. Then we have to get the equations so that one of our variables has opposite coefficients. This might already be done for you. This might require you to multiply just one of your equations by number, or as we did in number 6, we had to multiply both equations by number. Alright, So let's go take a look at number 9. So number 9 says, what is the solution to the system equations? They've already got it nicely lined up for us, so that's good. Let's see, do we have opposite coefficients? Doesn't look like it, so we could do a couple of different things here. If I wanted to get my x's to be the same, notice I'd have to multiply both equations by something. Let's take a look at our y's. If I want to get my y's to be the same, I could multiply just the second equation. We want to get a negative 12, so it cancels out with my top 12 here. So negative 4 times 3 would give me negative 12. So that's what I'm going to multiply by. Multiply the entire equation by 3. So I multiply this out, I get 9x minus 12y. 3 times 17. Let's see, 3 times 10 is 30. 3 times 7 is 21, so that would give us 50. Okay. Again, for our sake of having to deal with fewer, not having so much in our way visually, I'm going to go and rewrite my equation from the top one. Okay, so I'm done with this guy. Here's my new equation here, my 9x. And I'm going to rewrite the top one. So negative 2x. There's one. So rewriting it. Negative 2x plus 12y equals negative 30. And when I add these together, 9 and negative 2x is 7x. Negative 12 plus 12y cancels out. And 51 plus negative 30 is 24. So 7x is 21. Divide by 7 on both sides. And x equals 3. So you can look at our answer choices, and anything that has x equals 3 is a possible answer. Alright, so A, x is negative 2, so that won't work. B, x is negative 3, but we want positive, so that won't work. C, x is 3. And D, x is 4, so that won't work either. Now at this point, it'd be good to double check your solution to make sure it works. And in fact, we should be checking each solution using our calculators. Or you can use Google Math, but calculators might be a little bit quicker. So I need to check this in my calculator. And again, we should be checking every solution in the calculator. So x is 3, y is negative 2. So when I check this in my calculator, what I'm going to do is take x and put it in for x, and y and put it in for y. So technically what I'm going to put in my calculator is negative 2 times 3, because that's x, plus 12 times negative 2, because that's y. And I'm going to check to see if this equals negative 3. Then the same idea for my second equation. 3 times 3, because that is x, minus 4 times negative 2, because that's y, should equal 17. If it works for both, then I know that I have the correct solution. So again, a solution to a system is the one ordered pair that works in both equations. Alright, so let's go ahead and do this on our calculator. So negative 2 times 3 plus 12 times, parentheses, negative 2. And indeed that equals negative 30, so it worked for that first one. Let's check our second equation. 3 times 3 minus 4 times, parentheses, negative 2. And does that equal negative 17? Oh, sorry, positive 17. It does, indeed it does. So it works for both solutions, or both equations, so we know that is indeed the solution. And again, when you're doing these, to help make sure that you get it correct on a test, check your answers. If it's wrong, then you know that you made a mistake somewhere. Alright, I do believe we have covered them all. Double check. Indeed. Alright, so your homework is worksheet 6. That is due next class. Remember that you also have your e-cart test due Sunday at midnight, 11:59 p.m. So between now and Monday, when we have our next class, you need to make sure you accomplish worksheet 6 as well as the e-cart. Write down the problems, or write down your work you do for your e-cart, and that's what we'll be collecting.